move on to understanding acids, bases, and salts in detail, we can quickly recap what we already know about them. The word acid sounds scary, right? It comes from the Latin word acidus, which means sour. Yes, most acids taste sour. Lemons, for instance, have acid, and you surely know how lemons taste. And we'd also seen that acids turn blue litmus paper red. Based on their occurrence, they are divided into two types: natural acids and mineral acids. As the name suggests, natural acids are obtained from natural sources. They're also called as organic acids. Citric acid, which we get from citrus fruits, is an organic acid. Mineral acids, on the other hand, are acids that are prepared using minerals. They are also known as man-made acids or inorganic acids. Nitric acid is an example of mineral acid. What about bases? You can think of them as being opposite to acids. They are bitter in taste and turn red litmus paper blue. Sodium carbonate and lime are examples of bases. What are salts then? Is common salt a salt? What are the chemical properties of acids and bases? How do they react with metals? How do they react with each other? Is there any scale which helps us understand if a substance is an acid or a base? Answer to all these questions and much more in the coming videos. Happy learning! To understand how acids react with metals, we can perform a very simple experiment. Make sure you're assisted by your teacher when you're performing this experiment. Take a stand and using the clamp we have the test tube placed as follows. In this test tube, we add 5 milliliters of dilute sulfuric acid and then add a few pieces of zinc granules to it. What do you observe? You will observe that some gas comes from the surface of zinc granules. You'll see bubbles being formed. Now on the right, place some soap solution in a container and using the delivery tube, pass the gas through the soap solution. What do you observe here? You will see bubbles being formed in the soap solution, right? What's being released is nothing but hydrogen gas. And how do you test for hydrogen gas? The characteristic test for hydrogen gas is burning with pop sound. If we bring a lighted candle here, the gas will burn with a pop sound. This confirms the evolution of hydrogen gas. You can also try replacing the acid with other acids like hydrochloric acid or nitric acid and you will see a similar reaction. In case of hydrochloric acid, the reaction looks like this. Hydrogen gas and zinc chloride are formed when hydrochloric acid reacts with zinc metal. Notice what happened though. Zinc being more active displaced the hydrogen from the acid to give us zinc chloride. What is zinc chloride? It's a salt. So how can we summarize the reaction of an acid with a metal? Acid reacts with metal to give us salt and hydrogen gas. What about bases reacting with metals? Just like acids, when an alkali or a base reacts with metal, it produces salt and hydrogen gas. For instance, sodium hydroxide reacts with zinc metal to give us sodium zincate and hydrogen gas. So that's how acids and bases react with most metals. Do you know how acids react with metal carbonates and metal hydrocarbonates? We will see that in the next video. How do acids react with metal carbonates? Sodium carbonate is an example of a metal carbonate. To understand how they react, let's create a setup like this. We add around half a gram of sodium carbonate to the test tube and then add dilute hydrochloric acid to it. In this other test tube, we have lime water and we pass the gas produced in this reaction to this test tube via the delivery tube. When hydrochloric acid reacts with sodium carbonate, the following reaction takes place. We see that carbon dioxide gas is released. How can we generalize this reaction? We can say that acids react with metal carbonate to give its respective salt, carbon dioxide and water. Yes, This is the general reaction of how acids react with metal carbonates. And the reaction of acids with metal hydrogen carbonates is also the same. So in place of sodium carbonate, if we had sodium hydrogen carbonate, the reaction would have looked like this: salt, carbon dioxide and water. Why did we have the other test tube with lime water? It is to test for evolution of carbon dioxide gas. Carbon dioxide turns lime water milky when passed through it. So on passing the carbon dioxide gas evolved through lime water, this is the reaction we get. This white precipitate is nothing but calcium carbonate. But wait, when excess carbon dioxide is passed through lime water, it makes the milky color of lime water disappear. Why? It's because of the formation of calcium hydrogen carbonate. Calcium hydrogen carbonate is soluble in water and hence the milky color of solution mixture disappears. How can we summarize what we learnt? All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. Do you know how acids react with bases? Watch the next video to know the answers. To understand how acids react with bases, we take about 2 milliliters of sodium hydroxide solution in a test tube and add a couple of drops of phenolphthalein solution to it. What do you notice about the color? Yes, the color of the solution turns pink. The indicator phenolphthalein is colorless in acidic solutions but goes pink in basic solutions. As sodium hydroxide is a base, the indicator turns pink. Now to see how bases react with acids, we add hydrochloric acid to this drop by drop. What do you observe? We see that the solution turns colorless again. So the colorless base turned pink and then again turned colorless after an acid was added. What does this prove? We can say that the effect of a base is neutralized or nullified by an acid. Does the reverse also happen? Will an acid be neutralized by a base? To find out, let's add a few drops of sodium hydroxide back to the above mixture. And yes, the pink color of the phenolphthalein reappears. That's because the effect of acid is neutralized by the base. So the reaction taking place here can be written like this. Sodium chloride is nothing but a salt. So an acid and a base react to give us salt and water. And guess what such a reaction is called? It's called a neutralization reaction. A base reacts with acid to give us salt and water. In a similar way, calcium chloride is formed along with water when hydrochloric acid reacts with calcium hydroxide. Can you think of a more practical reaction? When we have acidity, our stomach produces excess acid, which is nothing but hydrochloric acid. And this acid is very harmful for the walls of our stomach, which is why we get that burning sensation. So to neutralize the acid, what we use is an antacid. Antacids, as you would have guessed, are nothing but bases. The antacid reacts with the base to give salt and water. And that gives us relief.